let's talk about this problem from the homework. Remember, I need you to find three things: zeros, horizontal asymptotes, and vertical asymptotes. Now, refer to your notes, please. Zeros, horizontal asymptotes, and vertical asymptotes. Now, in your notes, in that booklet you're working on yesterday, how do you find zeros? Where the numerator is equal to 0. Where does this numerator equal 0? Never does. 1 doesn't equal 0, and it never will. So there aren't any zeros. So what that means is this graph will never cross the x-axis. Okay? Turn around, Hayden. Now, your horizontal asymptotes. You have a chart in your booklet that says to compare the degrees. Remember? If you open up that booklet, it's on the left side. And it says you compare the degrees. So let's look at the top. That top is what we call a constant. What's the degree of that constant? The degree of a constant is always 0. What's the degree, meaning the biggest exponent that you see in the denominator? 1. The degree of the top is smaller than the degree of the bottom. So what's your horizontal asymptote? Y equals 0. Your horizontal asymptote is y equals 0. Yes, ma'am. Your vertical asymptote, look in your notes. Where does a vertical asymptote come from? I'm glad it didn't hit my toe. When the denominator equals 0. Now I want you to look at that denominator, x plus 2. What x value makes that denominator equal to 0? So x equals -2. Now, did you have trouble getting those three things when you were trying to work on those three problems? It was the graph? Okay. So now is where you take your ruler and your colored pencil and you draw in your asymptotes. Now remember, a horizontal asymptote means it's a horizontal line, so it's going this way. And you're going to draw it at y equals 0. So you're going to go right here. Sorry? Your vertical asymptote is at x equal -2. Vertical means it's going up and down. So you got here. Now, so the part that you had trouble with was the points, maybe? Trey said maybe the points. Okay. I want you to look. We have one vertical asymptote. So that one vertical asymptote divides the graph into two parts. The part on the left of the vertical asymptote and the part on the right of the vertical asymptote. Yes? So what we want is 3x values to the left of the vertical asymptote and 3x values to the right of the vertical asymptote. So you're just going to go and make two charts, one for the left and one for the right. Now you can make it in one chart, but I just thought it might be easier if we separated them. I want you to pick three numbers that are smaller than or to the left of -2. Yeah, -3, -4, -5. Pick three numbers that are to the right of x equal -2. I could do 3, 4, 5. Let's get a little closer also, though. How about -1, 0, and 1? How about those? All right. Now let's talk about how to go to your calculator and find those points. I'm plotting the points that we found on our calculator. -4, -1/2, -5, -1/3. Can you see what's happening there? It's going like so. Now negative 1, 1, 0, 1/2, 1, 1/3. And I hope you can see what's happening there. Now listen, when you draw these graphs, what I do not want to see, I do not want to see this. Okay? Don't give me some little fiddle farting tiny old pitiful graph. You give me a graph. That's what I want to see. Okay, so hopefully that helps. Now what I want us to do, I want us to have at least half an hour, at least, hopefully more than that, for you to work today so that you have the calculator in your hand. Now, yesterday we talked briefly about a problem that had two vertical asymptotes. You remember? Was it this one right here? Somebody tell me, was it this one? Yes. So let's do a quick review, and we will talk domain and range today. We didn't talk about that yesterday. What I will always encourage you to do is to factor. Okay? So if we factor that numerator, what have we got? What do you see in that numerator? You see a GCF. You see a GCF first, which is what? 3x. 3x times what? X minus 4. The bottom. Yes? Zeros. Horizontal asymptotes, vertical asymptotes. I know we did it, but there were some people who are here now who were not here yesterday, and this is, I hope, helping you review a little bit. How do we find zeros? When the numerator is 0. Now I want you to look at this piece right here. When is that equal to 0? When x is 0. When is this equal to 0? When x is 4. So I have two zeros. When x is 0 and when x is 4. Now, if we go over to your graph, when we go over to your graph, x is 0, x is 4. Okay, that's fine. Horizontal asymptote. You compare the exponents, the degree. What's the degree of the top? 2. What's the degree of the bottom? 2. They are the same. No, they're the same. When the degrees are the same, it's the coefficients. 3 divided by 1 is 3. Your horizontal asymptote is y equals 3. Now, if we go draw that in, horizontal, it's a line that goes this way. Y equals 3. So you got a line right there. How do you find your vertical asymptote? When the denominator is 0. X equals 3 and x equal negative 1. Right. X equals 3 and x equal negative 1. So x equals 3, you're going to go over here to x equal 3. And x equal negative 1, you're going to go here to x equal negative 1. And that's what you need to have filled in so far. I'm just going to put in the y values that I see for these three x values. Just round to the nearest tenth, that's fine. Are you getting the same numbers I'm getting? You getting those? Guys, you got to hang with me, all right? We have a test Wednesday. That test is not changing.
What happens if, hear me out,
All right, let's plot those points. -2, 7.2. -3, guys, hush. -3, 5.25. And all you can do is approximate. There's nothing else you can do. And -4, 4.6. That's the best we can do. Do you have some sense now of what the graph looks like in that section? So let's go ahead and draw what you see in that section. Okay? Have you got that? Now, we're going to go to this section. We're going to save the middle for last. So let's pick, look, we've already got 1 point, right? So how many more do we need? Just 2. So guys, listen, I am not in the mood to tell you to hush. I don't want to yell. We've already got 1, 2, 3. We've already got x equal 4. Let's pick 2 more numbers. Pick 5 and 6. Go back to your table and see what the y values are for 5 and 6. Okay. And 6? Close enough, yeah. So 5, 1.25, and 6 is 1.7. Do you have some sense now of what that piece looks like? That piece is going to go like so. Okay, are we good so far? All right, now we've just got one more. I'm sorry. Now, last piece. Shh. We have already got one piece in between, excuse me, 1 point in between those two. We've got x equals 0. How many more do we need? 2 more, because I want 3 in each section. Let's pick x equal 1 and x equal 2. Now, go to your graph, or go to your table. 1, I see 2.25, and 2, I see 4. So 1, 2.25, and at 2, I see 4. Now this is a graph that we say behaves badly. I told you yesterday that a graph is not going to cross an asymptote. There is only one time that it can. And that is if you have more than one vertical asymptote. It is possible that in between that the graph will cross. That's possible. So let me show you how this is going to look. Where is it? Ah. Oh, what did I just do? So it's going to look like this. Now, if you were still unsure, even though you had plotted those points, you can look, you can just hit graph because you've got the equation in y equals. You can just hit graph and look at it to make sure your points make sense. You're not going to do anything more complicated than this one. Okay. Wait, there was a number 3 down there, wasn't there? Let me see how many of these I feel like I want us to work. We're going to work this one for sure. Okay, here we go. What are the 3 things that I want you to do before you go to your calculator? Zeros, horizontal asymptotes, and vertical asymptotes. Now, listen, I am asking the same questions over and over because I think that's one of the only ways I can get it in your brain. How do you find zeros? Good, when the numerator is 0. When is negative 12 equal to 0? Never. So what are your zeros? Right. Horizontal asymptotes, what do? You compare the degrees of the top and the bottom. The top is a constant. There's no variable with it. What's the degree? 0. The degree of a constant is 0. What's the degree of the bottom? 2. If the degree of the top is smaller than the degree of the bottom, y equals 0 is your horizontal asymptote. Again, you will understand why those rules work if and when you take calculus. I said if and when. If and when. That's okay. Horizontal asymptote, y equals 0. Draw it. Now, how do we find vertical asymptotes? When the denominator is 0. I want you to look at this denominator. Okay, I've heard 3 times from 3 very good students that that's a difference of 2 squares. Is that a difference of 2 squares? It's not a difference. It is not a difference. It's a sum of 2 squares. I don't know how to factor a sum of 2 squares. Now, here's what we're going to do. Any x plus, it won't factor. So let's subtract 4 from both sides. That's right. Aha.
But that's not right.
That's right. That's imaginary. We can't graph an imaginary number.
Oh, yeah. Yeah.
We'll do fist bump.
0. No, you put your sleeve up like this. Yeah.
Oh. Well, I don't think that'll work.
Oh my God.
Now, shh, this will never happen. So I don't have any vertical asymptotes.
So what's it gonna be?
I don't have any.
None.
There aren't any.
None.
So listen, this horizontal asymptote's all I got. So here's my question to you. How many pieces is this thing divided into? It's only divided by vertical asymptotes. So it's just one big piece. All right. Now, I do not want you to graph. I do not want you to see what this looks like yet. You did. Okay, good. When you have a setup like this, here's what I want you to do. We're going to pick 0, 1, and 2. And we're going to pick -1 and -2. Okay? Put that equation in y1 and go to your table. Have you got your table? When x is 0, -3. When x is 1, -2.4. 2. What is -1? and -2. Okay, so let's plot them. Have you plotted them? 0, -3, 1, -2.4, 2, -1.5, -1. That's kind of interesting.
It's a parabola.
Well, now, it does look parabola-ish. Now, it does. In fact, here's what I want you to look at. Do you see that there is symmetry to this graph with respect to the y-axis? Do you see that if you folded this graph over the y-axis, these points and these points would lay right on top of each other? So I bet if I was able to just go over here on the right side and find a couple more x values, then I could just fold them over. So let's pick these. Let's pick 5 and let's pick 8. When x is 5 and when x is 8, figure out what the y values are. Come on, guys. I really need you working with me here, okay? I'm just not trying to be a bee, but come on. What do you get? -0.4. Okay. So if x is 5, y is -0.4, and if x is 8, y is -0.2. Do you see we are getting closer and closer to what? Yeah. And if you start scrolling down, if you just keep using your down arrow key, you're going to see that those y values are getting closer and closer to 0, but they're never going to get there. We can mirror these points on the other side because we know this thing has symmetry. So this sucker goes like this. Now don't make a V there. It's not a V. It's a curve. We're going to skip number 4. Let's go to number 5. Okay? Here we go. Please don't carry on other conversations, all right? Zeros, horizontal asymptotes, vertical asymptotes. Because I told you I wanted you to have half an hour, and we can get this problem done in 5 minutes or so. That will give you half an hour almost. What's the first thing I would suggest that you do here? Factor anything you can. Can you factor the numerator? Let's try. Zeros. And you put x equals. Don't just put down the numbers. So look, when x is -3 and when x is 2, you have x-intercepts. Plot those. Your horizontal asymptotes come from comparing the degrees of the top and the bottom. What's the degree of the top? 2. What's the degree of the bottom? 1. What's your horizontal asymptote? There is none. If the degree of the top is bigger than the degree of the bottom, there isn't one. So we don't have a horizontal asymptote. Please, when you're doing these, refer back to your notes. Refer back to that little booklet. Vertical asymptotes. What equals 0? X equals 0. When is that denominator 0? When x is 0. Draw that one in. That's all we've got. How many sections has the graph been divided into? 2. So I'm going to have to erase this so I have more space. But I rather like yellow, even though it's a little hard to see. Now, on the left side of the vertical asymptote, how many points do I already have? 1. So how many do I need? 2 more. -1 and -2. What about to the right side? I already have 1. Pick 2 more x values. 1 and 3. Now go graph it, or excuse me, don't graph it. Put it in y equals and go to your table. Are you getting numbers? When x is -2, y is 2. When x is -1, y is 6. When x is 1, y is -4. And when x is 3, y is 2. Y'all getting those numbers? Go plot them and let's see if we can figure out what our picture looks like. And then 1, -4, and 3, 2. Now this looks strange. Here's what I would suggest. Do you see on the left side, we've got here, here, here. Let's come up, let's get a point out here, like maybe -6. Now, I'm not making you do much more work because all you got to do is look on your calculator for -6, -4. So -6, -4. Then let's pick 6 over here. Six. That helps. If you're still unsure, just go graph. Just go graph. And see if your points make sense. This one goes like so. Do you feel a little bit better about these than you did when you walked in? Okay. So your job for the rest of this period is to get all the problems done on this worksheet. Get them all done. You should have sufficient graph paper.